Okay, welcome everybody. Thanks for coming. I think I've got my technical difficulties figured out. Um, Looks like we've got a good number of people on. Looks like about 16, 15 or 16. Not good. All right, so let's get started here. We're a couple minutes off the hour. Good afternoon. Welcome to the first webinar in our Virtual Tech Exchange series. I'm Bill Dickinson, Director of Technology at ESS. And today we'll be covering some key concepts of blockchain, as well as looking at what we have been doing here at ESS over the past couple of years with the technology. A little housekeeping: if you want to send me a question during the presentation, please do so using the Q&A chat feature. I will answer as many of them as I can towards the end of the hour. All right, so let's get started. Now, actually, before we get started, let's look at I want to remind everybody of the Tech Exchange series schedule, right, for the summer. Invitation flyers are going to go out in the next couple of days for the IBM presentation in a couple of weeks. And then later next week, I will get out the invitations for both the Oracle presentation as well as the open source one that we'll be doing in August. Okay, so just keep an eye out for them. All right, so everything that goes into a blockchain as a technology and a solution is a large topic, and not what I want to focus on in this extremely brief discussion. Putting aside all of the details, what I want you to take away from this webinar are two things. First, what types of problems blockchain is best suited for, and second, what are the key benefits that a blockchain solution provides to an appropriate problem. We'll start right up front with answering the big question. What is the business problem that we are trying to solve with blockchain? This will lead into briefly covering the two primary use cases for blockchain: cryptocurrencies and supply chain management. I'm not going to give you a lot of detail about either of those, but instead I just want to explain why they were good problems for the technology in the first place, based on the definition that we're going to give for the business problem. The idea here is to give you a clearer understanding of the type of problem best suited to blockchain, which will then help you identify other use cases that you can explore on your own. We will then get into the follow-on question. Now that we know the type of problem we are trying to solve, what is it about blockchain that makes it the right approach for solving that problem? A high-level answer to this question is pretty easy to state, but to provide the reasoning behind the simple statements will involve going into the actual technologies a bit. So we'll talk a bit about what those technologies are, how they come together to provide a comprehensive solution, and then get into the key technologies behind blockchain itself. That is the use of certain cryptographic controls to create a blockchain. At that point, you should have a better understanding of the type of business problems best suited for a blockchain solution and what it is about blockchain that makes it a good solution to that type of problem. I will then briefly cover several use cases that we have been working on here at ESS and to show you the potential of where you can go with blockchain. Finally, I will cover the educational and training opportunities that we have been developing here for anybody interested in diving into the real deep end of the blockchain pool. Okay. So let's start with what we are trying to solve. There is a fundamental business challenge that we have collectively been working on for decades, and that is how can we trust the digital relationships we all rely on in the 21st century business world? How do we know that the data we see is the correct data? How do we know that our personal data is safe when we give it to another business? In the digital world, everything is just bits and bytes, nothing tangible that we can touch or see. So are we continually asked to trust some external authority to maintain the data correctly for us? Every time we go on the internet to purchase goods, do our banking, pay our bills, or conduct just about any other facet of our business, we're implicitly putting our trust in someone else to manage, maintain, and protect the integrity of those transactions. This type of system is what we call a centralized system, where all of the authority is provided by some entity that we have allowed to take on that authority. It is not a wholly bad system, and it works well enough, as can be attested by the success of the last several decades of online businesses. However, when it doesn't work, when something goes wrong, Having all that authority resting in a centralized location means that those who are being served by that authority, meaning us, are at a severe disadvantage. I imagine we have all experienced at one point or another, maybe an online reseller insists that they've delivered our package, but it never showed up at our door. Or our bank tells us that we have less money in our checking account than we think we have. And then there's inevitably a long protracted dispute that costs both parties in time, money, and trust. And the last part, trust, is key to our discussions on why to use blockchain. The innovative idea here is that if we provide a better mechanism for ensuring trust in these digital relationships, then we will remove the need for disputes, which will save everyone money and time and improve business as a whole. Another way to state the problem is to ask what types of controls can we put on our digital processes, like managing our money or getting goods from one place to another, that can validate the integrity of the data and the process and allow us to trust that process is serving everyone equally and equitably. So those are all key concepts, and we're going to keep coming back to this idea of trust. I'm going to pick on the banks here for a little bit because they're an easy target. They're a prime example of a centralized authority that we've all dealt with at one point or another. We really don't have much of a choice here, do we? I mean, especially in business. We all have to have some relationship with a bank so that we can buy things and sell things. And in our modern relationship, in the modern world, that relationship is now almost entirely digital, if not entirely digital for almost all of us. I mean, how many of us no longer carry cash on them or rely entirely on electronic debit or credit to make purchases? How many of us do all of our banking and bookkeeping online? The final authority of what is in your bank account is really the bank, not really you. You can dispute charges or account balances, and in some cases you may win, but many times it will come down to the bank being the central authority and deciding that they are the ones that have the real data, regardless of what you have in your own checking account or what you say you have. And either way, both sides end up losing time, money, and trust and having to go through the dispute process in the first place. I know I've had situations with my own checking account where there's a discrepancy between what my ledger says I have and what the bank says I have. When the difference has been large, I would then go through the time-consuming process of working through it with the bank, probably over the phone. There have been times that I have missed something, and there have been times that the bank has done something wrong. There have been also times that the difference was so small, say maybe a couple dollars, where I didn't even bother trying to work it out with the bank and just assumed I miscalculated. So I adjusted my ledger to match what the bank said and just kept on going. I decided that my time was more valuable than going through the process of disputing the balance directly with the bank. We have a system where we have no real insight into the bank's data on us because we are not allowed to validate that data or their process for ourselves. We have to rely entirely on what the bank, that central authority, tells us about our money. And this is why blockchain is such a disruptive innovation to the banking industry. It turns the system on its head and provides mechanisms that allow all participants to validate the integrity of the data through cryptographic proofs that ensure we can trust that the business process is being followed correctly. So the problem we're trying to solve can be stated like this. How can we improve the level of trust in a digital business process involving multiple participants that do not currently have a mechanism or a good mechanism for validating each participant's activity? The blockchain approach gives us a decentralized one, where all participants in the business process have a copy of the data and a copy of the process logic itself, and can prove for themselves that the activity of the process is valid. Instead of putting our trust into a single centralized system, we distribute that trust to all participants in the system so that there is a proven collective consensus on the state of the data, meaning everyone agrees on the integrity of the data so everyone can trust the business process itself without having to rely on that central authority. Now, errors can still happen, of course, but through consensus, those errors are quickly detected and corrected across the entire system. And these concepts that we're seeing in bold on these slides are things that we're going to come back to again and again, because they are the key concepts behind blockchain and what it gives us. Okay, so we've been talking about banking, and let's talk about the alternative, the cryptocurrencies. Right? The basic question here is, how do we trust a centralized bank with our financial transactions? Right? Putting aside all the history and buzz around Bitcoin and cryptocurrencies, when we get down to it, what we're really talking about is a new way of managing financial transactions between people or entities or businesses. The idea is to allow people to transfer money directly between each other, and so remove a centralized bank as a middleman in the transaction. Using blockchain, cryptocurrencies can include controls and mechanisms to ensure data integrity so that all participants can derive a consensus of what each person has and can transfer to another person. That consensus provides the trust in the entire process without the need of a centralized entity to tell the participants what it is they can trust. And the supply chain management use case is not really that different. I mean, we're still talking about trust. And we could state the problem as being, how can we trust participants in the global supply chain management ecosystem to provide the goods and services they claim to offer? Using blockchain, we can provide mechanisms for managing the asset tracking transactions along the business process of getting goods transferred from the supplier to the buyer. Again, instead of putting trust in a single central repository, this time the supplier of the goods, we can distribute that trust across all participants in the supply chain, so everyone can derive consensus for themselves on who owns what, where the goods currently are, where the goods are supposed to be sent, and so on. Each step along the process is a separate transaction that needs to be recorded and validated to ensure the integrity of each transaction, which leads to greater trust in the business process itself. So here we get to the basics of what the blockchain does for us when we're talking about solving particular business problems. Right. We've got the decentralization, that provides the validation of the transactions. We've got a way of ensuring the integrity of the data through consensus. We have a way of proving the integrity of individual transactions through cryptographic mechanisms, which all come together to engender trust in the process. So we start out with the problem that has trust as a key factor, and then come up with a technology that can answer the questions of how to make the trust better. What we want to keep in mind is that when we are thinking about applying blockchain to a problem, what we are really aiming for is better management of the transactions of the process behind the problem. With blockchain, we do this in a decentralized way that provides mechanisms for deriving a collective consensus on data integrity of the activity occurring along the process. The result is a greater level of trust that the process is being followed equally and equitably by all participants. At a more granular level, we achieve this by managing the individual transactions that occur as a participant steps through the business process. The concept of a transaction is key, as it is the base unit of a blockchain. We'll see more of that in a couple slides. And here again, we see those terms: decentralized, integrity, and trust. These are all at the heart of the benefits of blockchain and are what drive the potential of the technology to transform nearly every aspect of our digital lives. And here I'm going to restate the key takeaway that we should be thinking about when we start discussing or thinking or whatever about blockchain and how we want to use it. The decentralized structure of the blockchain allows every participant in the process to verify for itself or to have consensus through cryptographic controls the integrity of the data and of each transaction, which allows all participants to trust the entire process. That is the key to what we want to do with blockchain. We want to be able to identify the problems that have trust as a key factor, and then use the mechanisms of blockchain to provide the level of trust required and needed. So let's take a little bit of a look at what a blockchain solution looks like, right? If we've already identified our problem, we've identified that one of the key factors is trust. What is it going to take? What type of technologies do we have to bring into play to make the solution possible? We obviously start with the business process. If we've identified that correctly, then we're on the right road. As we've been discussing, a suitable business process for blockchain is one where the need for improved trust is a key factor. Here at ESS, we've been thinking and researching what types of business problems are most suitable for blockchain for almost 2 years now. And I believe the answer is that most business processes are suitable once you look at the problem from the right angle. Trust is actually an issue that goes beyond whether people can trust each other or trust a business on the internet. There are also trust issues between computer processes and systems. We'll talk more about these in a little bit when we're talking about some of our use cases that we've been researching. But that's what we start. We always start with the business process. We have to make sure that the technology matches what we want, what we need in the requirements. The next thing we need is a distributed computer architecture that the digital process operates across. Of course, this is how we have been conducting business for quite some time. And really, all computer architectures are distributed architectures. It's just that at times we centralize certain pieces of that architecture to meet the needs of a particular business process. With blockchain, we simply use the distributed nature of our normal computing systems in a more direct way. The distributed network could be cloud-based or bare metal. It could be global or local. It really depends on what your need is. At ESS, we use several things. We have a restricted network just in the Software Innovation Lab. That can be one network. We have a more open network, the corporate network. Right? That could be another one. Or we could go global with the cloud infrastructure if we wanted to. Each one could be used as a separate distributed architecture, or we could build a blockchain solution that spans all of them. You then need a blockchain platform. And this is for running the various components of the blockchain network. That consists of various nodes that manage how the blockchain network operates. There are COTS blockchain platforms, like the ones offered by IBM and Oracle, as well as open source approaches that could be used. We'll discuss each of these in more detail in later tech exchanges this summer. So here, all I will say is that they are all made up of a number of additional servers that run specific pieces of the blockchain network and its capabilities. The next piece are smart contracts. Technically, smart contracts are part of the blockchain network as well, but they're developed outside of any specific blockchain platform, so I'm going to list them separately. Don't let the buzzword smart contract throw you off either. We are really just talking about software code that defines what actions can be taken within the blockchain network. They're effectively the business process rules distilled and defined as a code, and should it reflect a legal binding between all the participants. And the code is how the business process is supposed to run. And that's where the term smart contract comes from. The code really isn't anything new, and any programmer will find the structures very familiar. It uses typical programming patterns. We use JavaScript, we use Go, we can use Java. All of things will be familiar to an experienced computer professional. Finally, we have the user interfaces, which are created in the same way we have always created user interfaces. They can be mobile apps, web applications, desktop software, whatever works and fits the need of the business process. The blockchain platform itself will present REST APIs that the user interface can access to interact with the smart contracts and the blockchain network. But the basic approach is still the same, and it's the same we've been using and using to develop software tools and capabilities for decades. All these pieces come together as the final blockchain solution for the chosen business process. The point here is that very little of this is new. So the barrier of entry to experienced people is actually pretty low. As long as you've been doing some type of programming, some type of systems administration, you've been working with computers, learning this and learning the way the blockchain comes together is nothing really out of the ordinary. The only thing really new in all of this mix is the blockchain itself. And even that is still built off of existing technologies that we've all been using for quite some time. So we're still just scratching the surface, but it's worthwhile to take a little bit of a closer look at this new piece of technology, the blockchain itself. To do that, we have to talk a bit about cryptographic controls and how they are being used differently than in the past. Blockchain doesn't change the way any of the cryptography works, it just uses them differently. A blockchain solution makes use at some level of nearly all of the cryptographic primitives you see on the screen. And that's to provide basic blockchain capabilities that secure the data on a decentralized ecosystem. We use asymmetric cryptography for managing public and private keys, as we have always done. We use digital signatures to sign and verify each transaction, which we have always done. This provides proof of identity of the individual participants and ensures the authenticity and integrity of each transaction. The two, digital signatures and hash functions, are really at the key and the core of what we use blockchain for. But the real important one are the hash functions. This is the key to creating a blockchain, and as well as all the improvements that come with it. So we'll take a look at the hashing. A hash function is used to map some arbitrary sized set of data to a fixed size string that we call a hash. We can take any type of data, any block of data to begin with, as our input. We can put it into a hashing algorithm, which then translates that into a hash. If we think of the cryptocurrency use case, the input data is everything used in the transfer of the cryptocurrency. Who is initiating the transfer? What is their public key? How much do they have in their account? And who are they transferring the cryptocurrency to? This input data is run through the hash function to create the unique hash identity of that particular transaction. One of the key properties of hashing is that it always results in a unique hash value based off of the input data. If you change that input data even slightly, the hash value will be completely different and still unique. As you can see here, I've changed only one thing in my input data. I spelled dog wrong. And even though everything else is completely the same, the two hash values are completely different. And that's because the transactions are supposed to be completely different as well. Each transaction is unique. So each hash value, each hash identity is unique. In the cryptocurrency process, we give each transaction a unique hash identifier, which we can then use to validate any and all transactions across the distributed blockchain network. There's another key property of hashing that we use in blockchain called pre-image resistance. That's all just a fancy way of saying that it is infeasible to recreate the input data from the unique hash identifier. Infeasible doesn't mean impossible, only that it's too computationally costly to be worth making the attempt. It's easy enough to take some type of input data, run it through your hash algorithm, turn it into a hash. But to go the other way is very hard. The hashing algorithm is such that it's a one-way trip. So really, even if you have the hash identity, the identifier, there's really not any way to get back to the data that hash identifier is pointing at. And that's very important for what we call the immutability of the blockchain. The transactions can be added. You can add new ones that counteract a previous one, but you can never get rid of one that has already been added to the blockchain. Hashing is used to link one transaction to another in a chain of transactions. An individual transaction is a block, and the linking of a transaction is the chain in that blockchain. The hash of one block contains the hash of the previous block, which is what creates the chain of blocks. This chaining of hashes provides the basic mechanism used in the consensus algorithms that prove the integrity of the blockchain, and then in the entire process that the blockchain is managing. When a new transaction is to be registered on the blockchain, all participants in the decentralized system calculate what the new hash value of that transaction should be and must reach consensus on that hash value before the transaction can be added to the master blockchain. By reaching consensus, all participants can now trust that the transaction is valid. And by valid, we mean that it's unique and it hasn't been tampered with. Now, there are a lot of details running behind and alongside of this core concept, but this is the promise of blockchain in a nutshell. The trick is taking that promise and applying it to real-world problems in a meaningful way. It's great that we have the technological tools capable of ensuring the integrity of our blockchain and promoting trust between participants in a decentralized system. But what do we do with that? How do we take this from concept to application? Well, let's look at a couple of our use cases to see if we can figure that out. We'll look at the system event protection use case, a SCADA systems use case, and then a geospatial use case. The basic problem with system event protection is how to manage the events of individual network devices in such a way that we are 100% positive that the event as it occurred on the device is the same event that the security professional analyzes to determine malicious activity on the network. This question is at the heart of both the insider threat and the being hacked threats that everyone doing business in the digital world faces today. We can state this issue in a slightly different way. How can I trust each of my network devices, and how can I validate the integrity of the data being provided by each network device on my network? Thinking about the problem in light of trust and integrity tells us we have a problem suitable for a blockchain solution. Well, you may ask, why can't I trust the systems events generated by the devices on my network? The answer is that if there is a bad actor on your network, with the right type of permissions, that person can alter or delete specific system events or on specific devices to cover their tracks as they steal your data or insert malicious code. This could be someone who has hacked into your system, or it could be an internal system administrator bent on corporate espionage, or even an authorized user who made an honest mistake. Either way, we are talking about the keys to the castle problem. That is, that our current centralized approach to managing our networks relies on allowing elevated access to devices, giving bad actors a means of doing whatever it is they want to do to a device once they have that elevated access. System event logs are a critical component to our cybersecurity defense posture, as they are how we detect odd behavior on the network. For organizations like the federal government that take the cybersecurity defense very seriously, collection of system event and system scan logs are mandatory. These are all then collected for all devices across the network, processed in various ways, and eventually stored in a repository where the cybersecurity professionals tasked with protecting the network can access them for analysis. This keys to the castle problem means that there are multiple systems administrators along that process that have elevated privileges that, if they so desired, they could alter or delete critical system data. Elevated access is typically provided to individual administrators through the use of access control lists or administrative groups, which give anyone who hacks into the network the ability to elevate their own privileges so they could do the same. The problem then for the cybersecurity professionals is how can they trust that the system events and scans that they analyze are valid and have not been altered in any way? To do this, it involves protecting system events generated by all devices on a network so that analysts can be assured that the event recorded has not been tampered with by anyone with access to the devices or the network. The ultimate goal would be to have all system events from each device immediately published to a collective blockchain as individual transactions. The hashing techniques we discussed earlier tell us that each system event would then have its own unique hash identifier, and that the event information itself would not be exposed on the network. We also would note that all participants on the network, and here we mean each network device as a participant, would validate the event transaction and arrive at a consensus that it is a valid transaction before it could be added to the master blockchain of all events. The smart contracts doing the validation could be coded so that each event is digitally signed by the device reporting the event, which would provide verification that only an approved device could register a valid event, not a bad actor trying to do something malicious. In the end, the cybersecurity professionals would be able to trust that the event data they are analyzing is the real and true event data from authorized devices and has not been tampered with in any way. The basic design for an initial prototype for this has already been developed at the ESS Software Innovation Lab. As a first step, we have taken Windows EVT files, those are the actual event log files, being collected from individual devices, moved them into a secure compartment in an encrypted file repository, and then emitted them back out to an analyst workstation for analysis. Each device is registered on the blockchain network so that the activity is controlled by blockchain access lists, encryption, and auditability. This reduces where a bad actor could potentially manipulate the system events to the source device itself before the event is collected, and to the analyst workstation after the event files have been published to it. The next step would be to remove this risk by registering the individual device events directly on the blockchain and not as collected EVT files. The next use case involves SCADA systems. SCADA is an acronym for Supervisory Control and Data Acquisition, which is a computer system for gathering and analyzing real-time data of some sort. SCADA systems are typically used to monitor and control a plant or equipment in industries such as telecommunications, water and waste control, energy, oil and gas refining, and transportation. The problem is that for the federal government, these SCADA systems are aging and do not have proper protection against being hacked by malicious outside forces. Those that manage these systems are also concerned that upgrading the devices with the right protection will break the larger system. So they need a mechanism for providing additional protection without necessarily upgrading all of the hardware or infrastructure. Basically, the need is for a mechanism for sending commands to each device on the SCADA network that has been validated to have come from a trusted source, either another trusted device on the network or a trusted operator of the network. And once again, we're talking about trust. So once we're talking about trust, we can talk about blockchain. To avoid having to upgrade the entire SCADA infrastructure, the idea is to place a blockchain-aware device, like a Raspberry Pi, near each device on the SCADA network, and pass all of the commands for that device through it instead of over unprotected channels. Using a blockchain network, we can have each command digitally signed to prove it is from an authorized agent, encrypt the command code itself, add it as a valid transaction on the master blockchain through consensus by all participants on the network, and then have the receiving device validate the transaction again before decrypting the command to be run on the remote SCADA device. For the final use case, I use it for two reasons. First, my other job when I'm not doing blockchain stuff as the Director of Technology is developing 3D geospatial solutions for our government customer. And I think adding blockchain capabilities to a normal GIS data workflow would be super cool. Second, the wider context of this use case speaks to how blockchain solutions could completely transform how we interact in a digital world. As we have seen, blockchain is best suited to a business process where trust is a key factor in the desired solution. Here, we are looking at how to provide improved trust over who can see and change our data. The idea is to build a geospatial application that uses blockchain for identity management, meaning authentication, authorization, and access control, as well as for tracking the activity against the data. Every action related to the data, whether it is who connected to a piece of data or which geoprocess was used against the data, or if some external computer device tries to access the data, each one of those things is a transaction that can be recorded and validated through the blockchain process. In effect, building this capability from the ground up with blockchain at the center of the application allows us to ensure trust in the data management process at a very granular level. It would provide tools for explicitly managing access to the data by individuals, by devices, and even by software processes that attempt to change the data. In a wider context, we are talking about how we protect our personal data on the internet. The same idea could be applied to Office collaboration software like Office 365 or Google Docs. In those capabilities, you are trusting the centralized authority, that is Microsoft or Google, to protect and manage your documents correctly. And sometimes we may want that protection to extend to Microsoft and Google themselves. This concept could also be applied to protecting your medical information and giving you control over who is allowed to see or change that. Right now, you have relinquished that control to your doctor or the hospital or the health insurance company or the government. What we are talking about is the same thing as a digital wallet as used in cryptocurrency circles. That is building software with blockchain at its core so that control and management of that data is by you and not some other outside entity. All of the trust you keep control of. The last thing I want to cover today is a brief note about the education and training opportunities that ESS has been working on. Right now, we've got 4 of them. We have a one-day blockchain demystified course, which starts with basically what you've been hearing here, but then goes a little bit deeper into the blockchain technologies themselves, as well as ensuring that by the end of the day, you have a solid checklist that you can go down to determine what business problem you have is suitable for a blockchain solution. We also have multiple one-week-long blockchain boot camps on the individual platforms that you can use to create the blockchain network itself. We do have a 1 week for IBM's blockchain platform, for an Oracle blockchain platform, or if you wanted to go an open source route. These will go into much more detail and will give tutorials and hands-on experience using the platforms to develop the blockchain network that your blockchain solution would run on. And that is all of them. All right, then that worked out just about right to 40 minutes. Maybe a little bit less. If you have any questions, I will start looking over in the Q&A now and see if anybody has anything. Jason, I saw that you raised a hand. Do you want to post your Oh, Jason says, nope, that wasn't what he meant to do. All right, so we'll ignore Jason's raising of his hand. Well, we'll give everybody a minute or so to absorb and all right, I do have a question. ESS is plainly comfortable in all 3 chains. Is there one it would recommend? I assume here that, Edward, you're talking about IBM platform versus Oracle platform versus an open source platform. It really depends on what you want. Of course, as with any solution, if you're using a COTS product, you're going to have a shortcut to getting the details done, right? If you go with an open source solution, you're going to have to spend a lot more time in development, and a lot less time just solving the problem. The trade-off, of course, is that COTS products are going to cost you something. Open source is not going to cost you anything besides the time required to implement the solution. Do we prefer one over the other at the moment? No. I think all three have benefits and advantages and disadvantages. It really comes down to the solution or the problem that you're trying to solve, and then your resources in trying to solve that problem. Hopefully that answers that question. Edward says, thanks. Good. All right. Well, I'll give it another minute. And then if we don't have any other questions, we will wrap it up and close the webinar. You can always email me. You can email ESS as well at the innovation@exceptionalsoftware.com email address. That gets to me as well as anybody else that's been working within the Software Innovation Lab. I will be putting out the invitations to the next webinar, the next Tech Exchange in 2 weeks, over the weekend and into next week for the ones following that. Hopefully everybody can make that one as well. And of course, drop me an email if you need anything.